In this unit, we've been learning about parallel and perpendicular lines, and in this lesson, we're going to learn about the slopes of parallel and perpendicular lines. The objective is to relate slope to parallel and perpendicular lines. Look on the left side of your page. On the left side, it indicates that if two non-vertical lines are parallel, then their slopes are equal. In the next statement, we can make a statement of the converse of that statement and say that if the slopes of two distinct lines are equal, then those lines are going to be parallel. So the converse of that statement is also true. And the third statement says that any two vertical lines or horizontal lines are parallel. And that is because any vertical lines have an undefined slope, and all horizontal lines have a zero slope. So all vertical lines slopes are equal, and all horizontal line slopes are equal. Let's look at the characteristics of the slopes of perpendicular lines. The slopes of perpendicular lines, if two non-vertical lines are perpendicular, then the product of their slopes is -1. We can make the converse of that statement is also true. If the slopes of two lines have a product of -1, then those lines are going to be perpendicular. And any horizontal line and vertical line that intersect are going to be perpendicular. Numbers with a product of -1 are called opposite reciprocals. So, for example, if we have the number 2/3, then its opposite reciprocal is going to be, the reciprocal exchanges the numerator and denominator, just switches them. So the reciprocal is 3/2. The opposite reciprocal is the opposite sign, so it would be a -3/2. If you multiply these two together, if you multiply these two numbers together, then that's going to equal a -1. So those are the properties of perpendicular lines. In problem 1, we're checking for parallel lines. And so the question is, are the lines shown in the graph parallel? And explain why or why not. So to determine if they're parallel or not, we have to find the slope. So let's look at these lines. We'll call the first one A, and we'll call the second one line B. So for line A, let's look at the slope of line A. Slope of line A, since it is graphed, we can count the rise over the run, but be careful to note that the scale on the graph is going by 2s, okay? So the rise for this line is going up 2, 4, 6, 8, and the run is going right 4. So the slope of this line is 2. For line B, the slope of line B, once again, we look at rise over run. The rise, I'm going up 2, 4, 6, and then going right 3, and that is again a slope of 2. So yes, line A is parallel to line B because their slopes are equal. In problem 2, we're writing equations of parallel lines, and it asks what is the equation in slope-intercept form for the line parallel to the line with the equation y equals 4x minus 2, and it contains the point -2, -2. So to write the equation of a line, we need the slope of the line and a point on the line. So let's the slope of the line that we're given, compare it to y equals mx plus b, and the slope is going to be 4 because it's the coefficient of your x variable in slope-intercept form. So the slope of the line parallel to this one is also going to be 4 since their slopes are equal. So let's use the y-intercept, the point-intercept. Point slope form of a line. Y minus y1 is equal to m times x minus x1. And substitute in the point. So y minus a -2 is y plus 2. The slope of the parallel line is 4. And then x minus -2 is x plus 2. It asks for it in slope-intercept form, so we have to solve this for y to write it in y equal mx plus b form. So use your distributive property on the right side. Y plus 2 is 4x plus 8. Subtract 2 from both sides, and y is equal to 4x plus 6 is the equation of your line in slope-intercept form. In problem 3, we're checking for perpendicular lines, and we're supposed to determine if the lines shown in the graph are perpendicular and explain why or why not. So to determine if they are perpendicular, we need to know the slope of these lines. So let's name the line, let's name it C and D. So for line C, the slope of line C is going to be rise over run, which the rise, once again, it's going up by 2s, 2, 4, 6, 8, that's 9 is the rise, and then it went left 3 units. So that gives us a slope of -3. For line D, slope of line D is, once again, we have to go rise over run. Look at that. So the rise over the run for line D, the rise, it's going up 3, and then it went right 6. So the slope of this line is 1/2. If you multiply these two slopes together, a -3 times 1/2 is a -3/2, which is not equal to -1. So the answer is no. The slopes are not opposite reciprocals, and their product is not -1. Problem 4, we're writing equations of perpendicular lines. And the problem says what is an equation in slope-intercept form for the line perpendicular to the line with the equation y equals 3x plus 2 that contains the point 6, 2. So once again, we need the slope of the line that's perpendicular to the one given. the slope of the line that's given, if we compare it to y equals mx plus b, the slope is going to be 3 for this line. So the perpendicular slope, or the slope of the line that's perpendicular to this one, since 3 is actually 3 over 1, the reciprocal is 1/3, and it's the opposite reciprocal, so it's a negative 1/3. So now we're going to plug this into the point slope form of a line. Y minus y1 is equal to m times x minus x1. We're going to substitute in the point that we're given, 6, 2. So y minus 2 is our y value we're given. We're going to use the perpendicular slope, which is negative 1/3, and then x minus the x value we're given is 6 in the point. Since it asks for it in slope-intercept form, we need to solve this for y to get it in y equal mx plus b form. So use the distributive property to get y minus 2 is equal to a negative 1/3 x plus 2. Then add the 2 to both sides, and you have y equals a negative 1/3 x plus 4 is the equation of your line in slope-intercept form. The last problem is on the bottom left side of your page, problem 5, writing equations of perpendicular lines. This last example says, what is an equation for a line perpendicular to the one shown that contains the point 5, negative 1? So in order to be perpendicular to this line, we need to determine the slope of the given line. So the slope of the line in this graph, if we once again count rise over run, the rise, you're going up by 2's on the scale, so it's 10 over 4, which reduces down to 5/2 as the simplified slope. So if the slope of this line is 5/2, then the perpendicular slope is going to be a negative 2/5, opposite reciprocal. So let's look at the equation of the line. Once again, y minus y1 is equal to m times x minus x1. We're going to use the point slope form of the line to start with. And then put in the point that they give us, which is 5, negative 1. So y minus the negative 1 is y plus 1. That's equal to your perpendicular slope of a negative 2/5 times x minus 5, which is the x coordinate that you're given. If you want to put this, it doesn't indicate to put it in slope-intercept form, but if you want to put this into slope-intercept form, you would have y plus 1, use the distributive property, is a negative 2/5 x plus 2, and then you subtract the 1 from both sides to get y is equal to a negative 2/5 x plus 1.